Um, so I'm going to talk to you today about cloud computing and costing. But one of the tricks I learned early on is that kind of summarize what you want to say up front, and then it makes it easier. So cloud computing or cloud technology continues to change and change rapidly. So many of the things that I say today will be outdated 6 months from now. However, if you take away anything, cloud computing is really an IT outsourcing exercise. So the biggest thing you have to do is develop your as-is and your to-be analysis. So let me continue. I'm going to talk about the definition, the history, the types of services, the issues, some cloud costing models, the total cost of ownership, and a few confusions. So cloud started off as a slang in the tech industry, and it was generally portrayed in kind of a picture like a cloud, and that's where the term came from. Today, the cloud is a widely accepted term within the IT community. In the red at the bottom of the chart, in the simplest language, cloud computing is as simple as a sophisticated outsourcing of IT services. Cloud can be considered a form of COTS. It's purchasing off-the-shelf computing power or entire software as a services served up for you. So what's the cloud? It's an internet-based computing system where large groups of remote servers are networked. It shares data processing tasks, centralized data storage. Any computer-related task that's done entirely on the internet. It allows users to deal with software without having the hardware. And that's why people initially think cloud computing is so much cheaper. Everything is done remotely. Little or nothing is saved locally, and physical assets may be required. Over the past decade, business leaders have increasingly chosen to move to cloud systems. They no longer have to tie up capital in data center and equipment. They no longer have to continually increase and update their IT staff to main infrastructure. But the main questions for the estimator is, what's the purchase price? Call vendors, look online. Is it one time? Is it what's going on? What do I need to do to meet the requirements? And I'm going to talk more about that second bullet in bold there. That is probably one of the biggest things we miss. We think that we turn it over to the cloud and it all goes away. The modifications need to be made to tools hosted on the cloud. The SEER model has several K-bases, knowledge bases that would help with that. What are the risks for any vendor, and how well is COTS supported? If it breaks, will the vendor fix it? So here's what the NIST, National Institute of Standards and Technology, definition is. Computer security definition of NIST has provided a formal definition of cloud computing. 5 essentials: on-demand service, broad network access, resource pooling, rapid elasticity expansion, measured services, and it meets 6 ISO standards, and you can read what they are there, very similar: on-demand, broad network, resource pooling. Cloud computing, the definition is, it's a method of providing shared computing resources. And I kind of said this already, but most businesses today are already using some form of cloud services, even if they don't know it. I would suggest that many of you already subscribe to Microsoft 365 or to Slack or to DocuSign services. They're all just versions of the cloud. A fundamental notion of the cloud, both public and private, is that consumers utilize computing resources only when they want to and are only charged for the resources they actually use. This is partially true. Sometimes you're paying for service. You've bought a capability and you're paying for that capability. If you don't use it, you still get charged for it. So what's the history of cloud computing? Well, start back in the 50s, 1950s, we all did mainframes. Then you saw the PCs come to fore. Then in the 1990s, you saw cloud architecture. And it was at this point, at about 2000, where people began to do data center consolidation efforts. So many of you who've been involved in software development, iceberg programs, or IT systems, you can remember the early 2000s where we were trying to move data system, where I'll give you an example. NASA US, the National Aeronautics and Aerospace Administration, has 10 centers located around the United States. And at one point, every center had its own data center. And so there was a big effort to try to consolidate these data centers into 2 to 3 locations. And that was the beginning of cloud computing, because in many cases, cloud computing is nothing more than consolidation of data services or moving your services off to another platform. 2010 and beyond, emergence of as a service, you'll see in just a minute, as a service, infrastructure as a service, platform as a service, software as a service. Matter of fact, I'm going to introduce a new term for you before we finish called everything as a service. So infrastructure as a service, it really deals with raw computing capability. IaaS, infrastructure as a service, is the most basic service and provides a server or servers in the cloud. Platform as a service supports developing software for computing systems that it needs. Platform as a service provides equipment and equipped with software development. Many of you will, you see where I've referenced .NET and Python and Ruby and Rails and Java. Many of you will remember the discussions early in our growth of talking about thin client and thick client services. Software as a service provides software to organizations. It's the largest and most developed service in cloud computing. It's a program or a suite of applications available within the cloud rather than a computer's hard drive. Now, cloud service models will continue to evolve, and as you can see, some of the ones you're hearing today are business process as a service, function as a service, identify as a service, and then I have XAA, anything as a service, and I'll just end up telling you that more will come. There will be more and more public and private initiatives that offer you the opportunity to offload computing requirements and hardware and software off of your machine onto a centrally controlled machine. So the question becomes, the NIST reference architecture is laid out here, kind of the cloud carrier, the cloud consumer, and the provider. But I really want to get down to the next issue, which is who are these providers and what are the issues associated with software, with cloud computing. So you really break the issues associated with cloud computing into 4 large blocks: security, privacy, performance, and legal compliance. I'll kind of go with them in reverse order. Legal compliance, if in the US, if you're dealing with medical information, there's certainly HIPAA requirements. You need to keep that information separate and private. Performance has to do with the speed with which the system operates. Privacy is closely related to security, but I want to take just a minute to talk about security. Probably the biggest hurdle for having corporations move to a cloud computing option was based on their concerns about security. I think I can say with some confidence that, and I recently gave a talk, I think, to the iSpace group on costing cybersecurity initiatives. Cybersecurity threats will continue to grow. I can tell you that today you are as secure in the cloud as you are almost anywhere. So those things need to be thought about. but most corporations have resolved the security issues. So cloud computing or IT outsourcing is a capital investment. You need a process, and in the center there, center right, I show what the process comes from Dan Galorath's book. At the bottom, I show the process that's presented by the GAO handbook, General Government Accounting Office, U.S. Government Accounting Office. It doesn't really matter what the process is, but you need to understand that doing a cloud cost estimate requires the same kind of process you would do with any other. Now, I'd said define your requirement. As is versus the to be. I think that is language that you will all understand. But what that is saying is map out your current requirement and then map out what requirement you are going to outsource. One of the biggest issues in cloud computing today is that I end up buying services I don't need and then not buying services I do need. I'll talk more about those in just a minute. So here are the major cloud computing models: Amazon Web System, Cloud Health, Spot, Azure, Google Cloud. Each of these have their advantages and or disadvantage. Each of these actually provide a model that allows you to go in and cost the services. And if you'd like, at another time, I could come back and demonstrate a couple of those models for you. They're relatively simple to use, but again, the problem with these commercial models is that they only cost what you put in the system. So if you don't know everything that you want to buy, you could end up missing things. So Amazon Web Services, each of the public cloud providers has a built-in console. The pros, it's good for small scales when you have a relatively simple function, a few teams. The con, it does require good tag hygiene to figure what you're paying for and what's being monitored and not monitored. It's not built for you to be proactive. It's only built for you to kind of see the cost reports. So these models, these commercial models, and the next one I talk about is Azure, but they have the same issues, just slightly different interfaces. They are telling you what the cost to procure the resource and the monthly, weekly, or annual maintenance fee associated with those resources. Again, you have to know what you are buying or not buying in the process. Common cost drivers. So, excuse me. This is a chart that I would ask you to just take a minute to look at. Three things are commonly overlooked when you do cloud costing. Migration costs. There is some cost to you to move storage sites for the number of physical servers you need to buy and that you have, and the number of virtual machines. So many people, if you use any of the Amazon or Azure or other commercial models, they are not going to include migration cost because that's not a service you're buying from these. These are inside cost. Annual cost, storage size, number of servers, virtual machines, complexity of the workload, gigabytes of RAM, gigabytes of storage. It is very, very easy to over or under purchase those unless you've really scoped your requirement. Infrastructure as a service, the same thing, CPU and memory. And again, this chart shows you the dependent variables and the variables associated with cloud costing and some of the major issues there. Cloud costing really is just what I talked about. Decisions require a process, identify the ground rules, establish the requirement, describe the project, focus on project-specific risk drivers, review and validate the estimate. Understand the total cost of ownership. So many times when a person does an IT outsourcing or cloud computing exercise, they only look at the cost of procuring the assets. And I can't tell you how many times we Galorath have seen an organization move to a cloud computing solution only to find out that they had major pieces of hardware still operating relatively dormant in their environment. So there's a lot of cleanup and thought that needs to go into this process. So there is a SEER IT cost estimating model that allows you to look at three main blocks: servers, storage, and network. It allows you to build an IT infrastructure, a work breakdown structure, if you will, so that you can cost each one of these specific items. This is just an exercise that we ran where we were able to lay out the hours, the label costs, the material cost, and actually do a risk analysis around those things. SEER IT gives you some interesting charts to look at and compare that. But not everything. So probably, as I said, slide 17 was a key slide for you to take away, which were the drivers. This is a key slide for you to take away. Not everything is in the cloud. Deciding to move to the cloud is a decision about outsourcing. A cloud service is an application or device which is accessed through the internet. Each type of cloud service varies between how much of the service is organizationally managed and how much internally, that is, and how much is cloud provider managed. SEER IT cost and other cost models have the capability built in it with a parametric cost model, but it also has the ability to do total life cycle costing. So you need that's the key takeaway here, is that when you use one of the simple models to assess the cost of moving to the cloud, you need to remember that not everything is going to be in the cloud. So there are a number of very interesting models out there. This is one that David Litcham put together. It is a very top level model, and you should read his documentation. It is a parametric model that talks about the number of workloads, the number of workstations, the security requirement, the monitoring requirements in the cloud, and we work a formula out there. However, if you read his detailed analysis of this cost model, he will tell you that this is a starting point. This gives you a top-level assessment of the cost of moving to the cloud. It's a good starting point, but not a complete solution. So if you were trying to determine just yes or no on cloud, this is a good starting point. There's also some interesting work that was done by Price Systems and the MITRE Corporation that laid out predictive analytics that used computing hours and computer storage and developed a number of cost estimating relationships. And again, in the presentation document where these came from, they are useful for estimating specific pieces of the decision to move to the cloud. There was a recent update to that in 2020 that provided some more information on that. So the bottom line is there's a suite of SEER tools that allow you to do cloud cost estimating. The key thing is to determine what you want to outsource, understand what resources you will keep internally, and then determine the cost for all of those. I would say the two biggest mistakes that people make in trying to analyze a movement to the cloud is not recognizing costs that will remain with you and underestimating or overestimating the services that will be required. And I think that's the end with, are there any questions?
Yes, we have one question from Bonnie Brown here. The cost models that you showed from in the beginning, that are those cost models just the cost you're paying to the cloud provider?
Yes, the simple answer to that question is yes. They're top level cost models, yes, but not detailed cost models.
Do we have any more questions? Please put it in the chat.
And let me, while I wait for other questions, let me answer that a little further. Those cost models are just the services you are paying for. And you define the services you want to buy. And if your definition of the services you want to buy is that definition too large or too small, you will over or underestimate the cost to you. And sometimes there's a severe penalty to go back and buy additional services. So, but in the end, it's not different from most software or IT decisions. Your estimate is only good as your definition of the requirement.
Yeah. Yeah, that's true. Everywhere. Yeah. No, I don't think any more is coming up, but everyone knows. Yeah. Go ahead, Bob.
I'm just going to say, let me end with one closing thought that I started with. This area of technology is evolving extremely quickly, and you'll need to stay on top of what the options are, who the competitors are, and what the services are. The general outline that I've laid is valid, but the specifics will change drastically in the next 6 months.
Yeah.
Thank you.